Lesson 2.1 is the language of functions. So if a bakery charges $2 per muffin and customers get a $2 discount for every 6 muffins they buy, which of these two statements is true? The cost C is a function of the number of muffins, or the number of muffins is a function of the cost. So we're talking about like what depends on what. So is the cost dependent on the number of muffins you buy? Yeah, that's definitely true. Is the number dependent on the cost? No, usually you don't go to a store and give money and say, like, give me however much I get. That's kind of weird, right? So then again, independent variable, that is the number of muffins, because that's kind of what you're choosing. That's what you have control over. And the dependent variable is your cost, because that depends on the number of muffins. So now if we look at domain and range, domain is our x values and range is our y values. So let's look at what those would be. So you can't buy negative muffins, right? Because that would be weird. So let's start with 0. When you buy 0 muffins, you pay 0. What a deal. No muffins, no money. When you buy 1 muffin, it's $2. 2 muffins, you get another $2, so $4. 3 muffins would be $6. 4 muffins is $8. 5 muffins is $10. 6 muffins is $12. Oops, no, it's not. You get a $2 discount for every 6 muffins. So that's actually still 10. But once you get to 7 muffins, that would be $12. So if we look at this, the domain, which is again our x values, if you look at our domain, we have all positive integers. Actually, all integers greater than or equal to 0, because you can buy 0 muffins. You just don't pay anything for it, okay? But if you look at our range, which is our y values, we only have even numbers. So our range is all even integers greater than or equal to 0. We can also talk about domain and range when we have a graph. So we have y equals 2 to the x minus 4 graph to the right. The domain is our x values, and so we're looking at from left to right, what values can you have for x's. And it turns out you can have all the values, because if this keeps going, eventually this graph will move all the way over to infinity. It's just going to the right kind of slowly. So our domain is negative infinity to infinity. You could say this funny looking R means all real numbers. Or maybe you say negative infinity, it's a terrible infinity sign, it's kind of like a fish, is less than x is less than infinity. Those are all good. For the range, we're going bottom to top, so, what values can y be? Well, it looks like y, oops, sorry about that, looks like y really doesn't start from the bottom until you get to negative 4. So we have a horizontal asymptote at y equals negative 4. So then our y values go from negative 4 to infinity. And negative 4 is not included because it's an asymptote. You could also say negative 4 is less than y is less than infinity. Or you could say negative 4 is less than f of x is less than infinity. So when you look at a graph, you can tell if it represents a function by using the vertical line test. So if we look at the graph on the left, anywhere we draw a vertical line, we could draw it there, we could draw it there, we could draw it there. That vertical line has only one intersection point. So it only hits the function once. So that right there is a function. Over here, anywhere you draw a vertical line, like there, there, here you could have one. But if it's ever possible to cross through more than one point, then it's not a function. So a vertical line, really any vertical line, has greater than one intersection point, more than one intersection point. If that's true, it's not a function. Suppose f is defined by this rule, f of x equals 4 times 1/2 to the x. Let's evaluate f of 5. So f of 5 will be 4 times 1/2 to the power of 5. This is the same as 4 times 1 to the 5th over 2 to the 5th, which is 4 times 1 over 32, which is 4 over 32, which simplifies to 1/8. Now we're looking at, does f of negative 2 plus 3 equal f of negative 2 plus 3? You know what? Get rid of the negative and the negative. Let's look at if f of 2 plus 3 equals f of 2 plus f of 3. So f of 2 plus 3 is just f of 5, which we already did. It's 1/8. F of 2 plus f of 3 will be equal to f of 2, which is 4 times 1/2 squared, plus f of 3, which is 4 times 1/2 cubed. This is 4 times 1/2 squared is 1 squared over 2 squared, or 1/4, plus 4 times 1/2 cubed, which is 1 cubed over 2 cubed, which is 1 over 8. This is just 1. 4 times 1/8 is 4 over 8, which is 1/2. So the question is, does 1/8 equal 1 plus 1.5? And the answer is definitely not. Now we will evaluate f of q plus 1. And this seems like it should be harder than it is, right? It sounds confusing to plug in a q plus 1, but really we just have 4 times 1/2, and instead of x, we have q plus 1. And that's it. We can't simplify or do anything else. So for this next example, and we're looking for g of t equals 2t squared minus 3t minus 2, do me a favor, pause the video. I was going to say turn off. You can turn it off, but really just pause the video for a minute or two and do these problems for me, and then come on back. Okay, so here we're going to evaluate g of negative 2, g of 3, and if you did g of 5, that's fine. I'm going to show you g of negative 5. So g of negative 2 is 2 times negative 2 squared minus 3 times negative 2 minus 2. Negative 2 squared is 4. 2 times 4 is 8. Negative 3 times negative 2 is 6. Negative 3 times negative 2 is 6, so plus 6 minus 2. So g of negative 2 is 12. G of 3 is 2 times 3 squared minus 3 times 3 minus 2. 2 times 3 squared, 2 times 9 is 18, minus 9 minus 2, which is 7. And g of negative 5, 2 times negative 5 squared minus 3 times negative 5 minus 2. 2 times 25 is 50. Negative 3 times negative 5 is 15, minus 2, 63. So the question here was really, sorry, I lost my train of thought. So we're looking at, does g of negative 2 minus g of 3 equal g of negative 2 minus 3? Well, g of negative 2 minus 3 is just g of negative 5. So does 12 minus 7 equal 63? No, definitely not. For our last piece, we are going to evaluate g of 3p plus 1. So g of 3p plus 1, well, obviously you have a bunch of p's in there, that's okay, is 2 times 3p plus 1 squared minus 3 times 3p plus 1 minus 2. So you might plug in here and be done, but it's not simplified, and I'll have to ask for you to simplify it, but if I do, you'll have to do more. So this is the same as 2 times 3p plus 1 times 3p plus 1 minus 3 times 3p plus 1 minus 2. I'm going to bring the 2 down and multiply these. So 3p times 3p is 9p squared. 3p times 1 plus 3p plus another 3p plus 1 minus 3 times 3p is 9p, negative 3 times 1 is negative 3, minus 2. We're getting there. So this is 2 times 9p squared, 18p squared, 2 times 3p, 6p, 2 times 3p, 6p, 2 times 1 is 2, minus 9p. Negative 3 minus 2 is negative 5. Whew. Okay, we're getting there. 18p squared, 6 plus 6 is 12, minus 9 is 3p. 2 minus 5 is negative 3. So our answer is g of 3p plus 1 equals 18p squared plus 3p minus 3.